data has a shape. Look at the whole crowd, not just one.
Welcome to the moonlit data marsh. This is a quiet wetland where numerical values take on physical forms. Kit, a small golden Shiba Inu, settles low at the water's edge to observe the landscape. This dot plot displays read-aloud times in minutes: 4, 5, 5, 6, and 8. When these numbers are arranged together as shells in the sand, they form a distinct physical shape. We identify the spatial middle of this arrangement to find the center. In this specific set, the distribution has a center around 5 minutes. The distance these points cover along the shore represents the spread. Here, the data stretches from 4 minutes to 8 minutes. Recognizing the physical center and the boundaries of a data cluster provides the foundation for understanding any distribution's overall shape. This collection of stones represents daily temperatures in degrees: 61, 62, 63, 63, 64, and 72. This environment shows what happens when data is uneven. Most of these temperatures are packed closely together. We call this a cluster, the area where the majority of the data points reside. Past the 64 mark, we find a wide expanse of empty water. This visual gap indicates a range of temperatures that were never recorded. Far across the gap sits the 72-degree mark. This isolated stone is a high value that changes how we describe the overall shape. Pause the video for a moment. Try to describe the cluster, the spread, and the high value of this temperature data on your own. A distribution's true shape includes its empty spaces and isolated outliers just as much as its tightly packed clusters. This numerical list shows the number of books read by students: 1, 2, 2, 3, 5, 7, and 7. Describing the center and shape of a list is difficult because the data lacks an immediate visual structure.
Where does it cluster? How wide does it spread? Shape tells the story.
This dot plot reveals the underlying shape as the pebbles roll into their proper columns. Translating a list into a graph makes the distribution visible. Now that we have a shape, we can identify the middle value. In this set, the center is 3 books. We can describe the physical spread as moving from 1 to 7. However, we can also calculate a single value to represent this distance. This equation on the driftwood shows the range. By subtracting the minimum value of 1 from the maximum value of 7, we find a range of 6 books. Converting raw lists into spatial arrangements allows us to accurately calculate range and locate the true center of data. We can now summarize the books read by students. It has a center of 3, a spread from 1 to 7, and a range of 6. This weathered slate lists the 3 pillars of a distribution. Every statistical question is answered by identifying the center, spread, and shape. Matching the mathematical values to the physical geometry in the scene proves their relationship. The environment shows how the numbers behave, and the notation records it. Numerical data forms a structured environment with predictable, measurable relationships. As Wren lifts off from the marsh, the core concepts of the distribution remain clearly anchored in the landscape.
You read the crowd. Center, spread, and shape. Collect your own data